Hi, welcome back. In this video, we're going to talk about the rhombus and the square. Make sure that you have seen already the previous videos on rectangles, parallelograms, right? Knowing those two is going to help us with today. So, rhombus and squares are both types of parallelograms. Let's begin with the rhombus. A rhombus, or rhombi for plural, is a parallelogram that has four congruent sides. Okay? So I'm going to make sure that I put tick marks here because all four sides are congruent. Previously, the parallelograms that we drew did not have to be congruent. Only the opposite sides were congruent. This one, all four sides are congruent, and the diagonals are perpendicular, which means these dotted lines intersect at exactly 90 degrees. So all of these are 90 degrees. This is 90, this is 90, this is 90. They're all 90 degree as an intersection. That's what makes a rhombus a very particular type of parallelogram. So knowing these two properties, diagonals intersect at 90 degrees, and that all the sides on the outside are congruent, let's begin. One last thing, actually. The diagonals also bisect the opposite angles. So because they're perpendicular, whatever angle we have here, it'll cut it into two equal angles. So this is going to be congruent to this angle. Same thing down here. Since opposite angles are congruent for a parallelogram, that means that the bottom ones will also be congruent. And they're going to be cut in half, cut into two equal parts. Similarly on this other side, this angle and this angle are opposite and congruent, and the lines will cut them into two equal angles. So here we have a couple of examples with rhombus. In the first example on the left, JK equals 12. This distance is 12. JN is 7. Let's find missing sides and missing lengths that we're looking for. If I'm looking for JM, I know that on the outside, all lengths are congruent. So I know JM is equal to 12. Now, to find JL, this length, from here to here, a rhombus is still a parallelogram, and this is still the midpoint. These diagonals are still bisecting each other, which means this length is also 7. So if we have 7 and 7, that means that the whole length is going to be 14. Now, to find MN and MK, I'm going to focus on a different color here. Let's start with MN. How do I find this particular length? Let's call it X, MN. Well, since the diagonals are perpendicular, they form a right triangle right here. And I can use Pythagorean theorem to solve for that missing length. And that's exactly what I'll do. I'll do a squared plus b squared equals 12 squared. I'm focusing on just that red triangle that I drew. If I do a little bit of math, I have x squared plus 49 equals 144. When I move the 49 over, I'm left with x squared equals 144 minus 49. $95. Square root both sides. X equals 9.75. We'll just do 9.8 for now, for rounding purposes. Or sorry, 9.7 if I'm rounding to the nearest tenth. So that means that this length is 9.7. MN is 9.7. And that means that MK, the full length, if that's 9.7, and this is 9.7, 9.7 plus 9.7 is 19.4. Let's try this next example. RT is 22. This full length is 22. And this full length, US, is 18. I know that this is a right angle. Since they're bisecting each other, the full length is 22 for RT, which makes this length 11 and 11. See if I can make that a little bit bigger. 11 and 11. Since US is 18, that makes this length 9 and 9. Now, if I wanted to find the length of VT, that's the first component, right? I already cut it in half, so VT from here to here, that's 11. UV, I already cut the segment in half. That makes this one 9. RS is the diagonal on the outside. Well, since I have two sides of a right triangle, I can use Pythagorean theorem again, right? And I can solve for the missing opposite side. So I have 11 squared plus 9 squared equals, let's call this variable x squared. 121 plus 81 equals x squared. 121 plus 81 is 202. When I square root both sides, x equals 14.2. So the outside length will be 14.2. Put this in blue. And if I wanted to find ST, this length should also be 14.2 because the length of the rhombus on the outside, they're all 14.2s. They're all equal in length. So I'm using the fact that the diagonals intersect at 90 degrees in order for me to be able to find any missing components there of a right triangle. Let's talk about angles now, okay? So here I am missing a lot of different angles. I want to make sure that I'm able to find any missing angle as long as I'm given one of the angles, okay? The thing to know from here is that the diagonals are going to bisect each angle. So each diagonal will cut the angle in half, which means angle 4 will equal angle 5. And this right here, we can start with this angle already. Angle 3 will equal 38 degrees. Because each of the angles will be cut into two equal parts. So if this is 38 as well, I know that the total of these two angles is 76 degrees. So all of these together is 76. Which means on the opposite side, these two together will be 76. And if I'm cutting them in half, they will be both 38 degrees. Right? In our parallelogram, opposite angles are congruent. So these angles are going to match these angles. 4 and 5 are both 38. And now I can look for angle 8. These diagonals, I'll put it in a different color. These diagonals are perpendicular, which means angle 8 forms a 90-degree angle. They're all 90 degrees. Now from here, I can look at a triangle individually if I wanted, or the parallelogram as a whole. If I focus on the triangle individually, I'm going to highlight this in, let's just say, pink. This angle alone, each triangle should add up to 180 degrees. If I already have 38 degrees and 90 degrees, I can figure out what angle 7 is going to be because they all add up to 180. Right? So for this pink triangle alone, I can do 38 plus 90, that's 128, plus angle 7 is equal to 180. I can subtract 128 from 180. Angle 7 should equal 52 degrees. So this little piece is 52, which means this one should also be 52 because the angle as a whole is being bisected, right? So angle 7 and angle 6 are both 52 degrees. Now, since these are congruent, on the opposite side, these will also be congruent. So angles 1 and 2 should also be 52 degrees. The key component here is that opposite angles are congruent and the diagonals are cutting those angles in half. That's why they're both 38, they're both 52 on opposite sides. And then on the intersection, it's 90 degrees. Now let's combine things in terms of variables, right? So far we've been doing just numbers and looking at the properties of a rhombus. Let's look at some variables. Here I have two sides of a rhombus being given. I have 9x minus 77, and I have PO, which is 3x plus 7. A rhombus is congruent on all sides. So that means that 9x minus 77 should equal 3x plus 7 in length. Once I solve for x, I will then go back and figure out what I'm looking for. But first I need to solve for my x once I identify the relationship. Move the 3x over. 6x minus 77 equals 7. Move the 77 over. 6x equals, is going to be 84. When you divide both by 6, you're going to get x equals 12. Is it 12? 84 divided by 6. 14, sorry. Now, I'm interested in finding the length of MP. MP is this length. Now, since all lengths are the same, I can literally plug this into any side I want. I'm going to plug it into this one because it seems like the simplest form. 3 times 7 plus 3 times x plus 7. So x is 14, so 3 times 14 plus 7. 3 times 14 is 42. And when you add 7, you get 49. That means that all the side lengths are 49. Therefore, this length is 49. That's our solution for MP. This next problem is dealing with angles. Since the diagonals bisect each angle, it's going to cut each angle into 2 equal parts. That tells me that 5x plus 1 should equal to the other angle, 8x minus 20. I identify the relationship, those two angles are congruent, and then I can solve. So I subtract 5x on both sides. 1 equals 3x minus 20. Move the 20 to the other side. 21 equals 3x. So when I divide, I should get x equals 7. Now, I'm interested in finding the measure of angle FED. This is the letter that you start with. Start and finish. So we're really measuring angle E. But I'm going to start with F. Let's do this in red. Start with F. E. D. I want to figure out this entire measure. What is that total going to be? Well, to do this, I'm going to plug x into what I already know. I can plug x in here and in here. When I plug it in there, I'm going to get 5 times 7 plus 1. 35 plus 1 is 36 degrees. When I plug it in over here, I should also get 36 degrees, which tells me, right, that this angle is 36 and this is 36. I can do this in several forms. Let's go back to the fact that this entire parallelogram adds up to 360 degrees. So, if this is 36 and 36, the total is 72 degrees. It's going to get a little messy. This is 72 degrees. On the opposite side, this is also 72 degrees. Since we're dealing with a quadrilateral, all four angles, angle C and angle E, all four of these angles will add up to 360. So I really just have 72 plus 72. Between those two angles, I get 144 degrees. And then I have two of these angles over here. Let's call this angle X and angle X. I have two of those, and that should be a total of 360. So, what's left over? I subtract 144 on both sides. 360 minus 144 is 216 degrees, which tells me there's 216 degrees left over from the two angles that I already know. When I divide it into the two angles, because they're congruent, I should have 108 degrees for angle E and 108 degrees for angle C. And that's how I find the measure of angle FED. FED is 108 degrees. If I wanted, I could divide it into two so that I can get each angle separately. But I'm interested in FED, so the total from here to here, 108 degrees. Okay, this covers it up pretty much for a rhombus. We spoke about how do you solve for missing side lengths or angles, depending on what you're looking for. Let's talk about a square for a little bit. A square is a parallelogram that has the properties of both a rectangle and a rhombus. This is why it's important that if you haven't watched the video on rectangles, that we get familiar with the properties of a rectangle. I'm going to draw a small sketch here of a rectangle. A rectangle, we have 90 degrees as our intersections, and the diagonals are congruent. They're equal in length. We also have a rhombus, which is a parallelogram with four congruent sides. Now, since these four sides are congruent and the diagonals intersect at 90 degrees, we have ourselves a rhombus. Together, if we merge these two rules together, we form exactly a square. And that's exactly what it is, right? All sides are going to be congruent, like the rhombus. All angles are 90 degrees, like the rectangle. The diagonals are going to be congruent. They're going to be the same length. And at the same time, they make a 90-degree angle. So a square has all of these properties combined. And it's still a parallelogram, right? So let's do some examples that talk about the relationships between these two properties combined into just one square. So here I have the PQRS is a square. So the length TR is 17. If this length is 17, let's find the measure of everything else. So let's start with PR. What is the full length? Well, since the diagonals are bisecting each other, that means that this length PT is also 17. So PR, the full length, will be 17 doubled. That's 34. QS is the other diagonal. Diagonals are going to be congruent like the rectangle. So if PR is 34, that means that SQ or QS is also 34. Or I can say this is 17, this is 17. They're all 17s. To find QT, I can see how it's also 17 as length. And then to find PQ, this outside, I'm going to lean on the fact that the diagonals are intersecting at 90 degrees. They're perpendicular. So I can look at this right triangle and say 17 squared plus 17 squared equals PQ, which is x squared. 17 squared is really just 289. So 289 plus 289 equals x squared. 289 plus 289 is 578. So when I solve for x, I get x equals 24.04. That's my length of PQ. And technically, a square is also a rhombus, which means they're all going to be equal to the same. 24.04, 24.04, 24.04. They're all equal to the same, right? Now let's talk about angles. Since the angles are equal to 90 degrees, right? This intersection is 90, this is 90, this is 90, and 90 like the rectangle. And the diagonals bisect each angle, which means each angle will be cut in half. What do we know about the angles? Well, then I know that each angle here is 45 degrees. This is 45 degrees, and it's going to be congruent all around. We have 4 triangles that are 45, 45, 90 triangles. So now we just got to figure out our measurements. PRS. PRS is relating to, we start with P, we're going to go to R from PRS. This angle is 45 degrees. STR, we're going to start at S, T, R. That means that this angle, T, is 90 degrees. PSR, we go to from P, S, R. It's just about learning how to read it, right? We start with the letter. We're measuring the letter in the middle, and we're going all the way to R. That's 90 degrees. And then lastly, QPR. QPR, from here to the bottom. This angle is 45. So as you can see here, now we can set up equations with variables, right? Our first scenario, we're given the angle here is 7x plus 3. Since this angle is a 90-degree angle and it's going to get cut in half, I know 7x plus 3 should equal 45 degrees. And then I can solve for x. Move 3 over. Seven x equals 42. And when you divide by 7, you get x equals 6. That's it. For this next one, STUV, we are given the length SW is 2x plus 13, and WU is equal to 8x minus 41. This is still the midpoint, right? This is still the rules of a parallelogram, which means these two are congruent. 2x plus 13 is still equal to 8x minus 41. A square is a parallelogram, which means the properties still apply. We combine like terms. We're left with 3. 13 equals 6x minus 41. When you move the 41 over, we're going to get 6x equals 54. Divide both by 6. X equals 9. Now, what I'm really interested in finding is the length of VT. VT is this length. The diagonals are congruent like rectangles, right? A square is a rectangle. Therefore, when I plug this back in into this information, I can plug it in here and into here. I can find the full length. So 2 times 9 plus 13, I get 18 plus 13. 18 plus 13 is 19, 20, 21, 31. One length of these is 31, so if I have 31 for one of them, if this is 31, that means that this is also 31. So the full length is 62. Therefore, VT, the full length, should equal 62. This is why it's important to watch the videos of parallelogram, the videos of a rectangle, right? They all add up together to each other to this ultimate shape. Let's sort of wrap everything up and let's put this together. So the way to think about it, we started with a parallelogram, the general shape of a parallelogram, where opposite sides were congruent and parallel, right? We also spoke about the properties of how the diagonals bisect each other, right? All of that stuff. This is going to be bisecting. We spoke about opposite angles being congruent, all of that stuff. From here, we then defined our parallelogram for a very particular parallelogram to be a rectangle. And the rectangle was defined as 4 right angles, and the diagonals were still bisecting each other, and they were also congruent. Then we introduced another shape called the rhombus, and the rhombus was a particular type of parallelogram where all 4 sides were the same length, and the diagonals intersected at 90 degrees. From here, the square came about. The square had both properties. So if I merge the rectangle and the rhombus, I created the square. I mean, not me, but the square gets created as a result, which then means all sides are congruent, the diagonals are congruent, and perpendicular, which means they make 90 degrees. The intersection is still the midpoint of the diagonals. The diagonals are 90 degrees. The square basically has all the properties of all of the shapes that follow it, right? So a square, this is why they said back in elementary, a square is a rectangle. But a rectangle isn't necessarily a square. The square will have all the properties of everything before it. So a square is a rhombus, and a square is a rectangle, and a square is a parallelogram. We can flow in that direction to show, just like we can show that a rectangle is a parallelogram. But just because it's a parallelogram does not mean that it can be a rhombus, right? A rectangle is a parallelogram. So as long as we're flowing in that direction of these red arrows, we can say a square has a property of a rectangle. The square has the properties of a rhombus. The square has a property of a parallelogram. Go in the upward flow of things, go in the upward direction, and all of those properties will flow through it as well. Alright guys, I hope this has helped. Please let us know if you have any questions. Don't forget to like and subscribe, and as always, we'll calculate later.